Let me introduce our next speaker. It's Juan Castell. He's the cluster manager of the Aragonese cluster of agricultural and livestock production means. And he's going to talk about a digital twin for nut orchards. So whenever you are ready, you can start, Juan.
Thank you very much, Ainara. So I can share my screen. Okay, you can see it.
Yes,
Okay.
perfectly.
Thank you. Thank you very much to the Universidad Pública de Navarra for this opportunity to share this project that take for us almost 30 months. It's a long project that we start in 2021. And when we start that project in 2021, everybody in the industry, in the manufacturing industry, talks about digital twins, but in agriculture, for farms, it didn't want a topic. So I think that project was a very innovative project, and it becomes early that the time is right now when everyone talks about digital twins. So this project was funded by the industry minister from Spain, and we get funded from three consecutive years, three consecutive calls, and that is a lot of important. But because we have to apply to each call, to each different call, and it gets evaluated and it gets approved every 3 years. So it's a I think it's a success case because it has very interesting results, and it has been evaluated 3 times. So the minister approved this project as an example. So let me start with the project. Why we start with this project? What was the concept or the motivation for this project? Well, in 2021 in Spain, there was a booming about nuts. We started a lot of farms trying to increase the amount of pistachio and hazelnut farms, almost in the center of the peninsula, and some of them also here in Aragon and Navarra. The farmers see that crop as a high profit, a very interesting investment, and it's going to be a long-term return. So it needs a very strong investment in the beginning. So there is a very strong and high food industry here in Spain. We have a very large production, and we are very well positioned in the global market. And the farmers, they are almost small and medium-sized farmers. It's a traditional crop here in Spain. In Aragon and in Navarra is dry. It's dry crops, not for water crop. We didn't, but here now we in the intensive and super intensive methods, they start to apply irrigation for these crops. What we see a very large technology gap. The digital twins what common conversation in the industry, in the other sectors like automotive, like aeronautic, or other confined manufacturer, but in the agriculture, in farms, in open fields, the digital twins was a very large change. It was an opportunity, but also there wasn't too many publication, too many reports, and it needs a very strong investigation and knowledge development. We see as a key difficulty that the farms, they are living systems, and in agriculture we have several years cycles. So this is another challenging situation, because all the data is going to be provided only one cycle, only 1 year. So we have to search how we are going to approach to this project, how we can accomplish this approach and to try to have success in this project. I have to say also that the consortium of the project of this 3-year project was 9 partners. CAMPAG was the coordinator. We are affiliated with the University of Zaragoza. Bitartist was the agri-food cluster from Castilla y León in the center of the peninsula. CTMet, a technological center from the south. Geospatium Lab, that was it's a SMEs that it has expertise about geopositional and maps developed hardware. 7E Data, it's a software company that is specialized in ERP for farms and for cooperatives. AgroIntelligent, it's a startup that is trying to impulse the precision agriculture in the Spanish farms. Zebra Ventures was also developing algorithms for artificial intelligence. Pistachio, it was a farm there in Castilla y León, and Smart City Cluster, it was also a cluster from the south of the peninsula that has a lot of SMEs that develops software about artificial intelligence. How we structure this project, this long-term project, we structure in 3 phases. In the phase 1, sorry, that start in 2021, we try to do a simple project. We try to establish a digital twin for only one exploitation from pistachio. Try to modelize to see what are the inputs, what are the outputs, what are the parameters that we have to know to try to automatize this digital twin. The second phase, from this twin of a single farm, we try to make a loop that the outputs of the farm is going to feed the digital twin set the next years for this farm. And in the third phase, we see that the reality of the farms, that they are not isolated entities in the field. They are connected. They had neighborhoods. They had another farms with another different crops. So we have to simulate this inter-farm relationship with artificial intelligence. This is the Gantt the top project timeline with sorry, with our work packages. We had all this from the beginning to the end, the coordination and the dissemination. We had a strong dissemination work for this project. And we start with some farm modeling with this focus group in the work package 2. You see that we finish in 2022 July, the first phase. We start in September of the 2023. We end in June of the 2023. And we start the last phase in September of 2023 and end this year in 2024. We also continue developing this project, these models, but the GEDEFEC project, that is how is this named, with the Minister of Industry, ends in March of 2024. So what we achieve in 2021 in phase 1 with this only farm digital twin. We try to model the farm. We establish several focus groups with the sector, some stakeholders, the academia, the farmers, the software providers, the technology provider, to see what is the model of the data, what data we have to know, what data we have to control, what what is the structures of the data and how we have to make this exchange of data to try to generate knowledge and to generate some sort of results. We also see how is now sensed this pistachio farm, what we need to put, what kind of sensor they are now, and what kind of sensor they didn't there in this farm. So try to see what we have to contact and what kind of sensor we have to incorporate in the farm. And also at the end, in the work package 4, we try to see all the data, see the structure of the data, how we have to fit the clusters, the computational operation cluster to see this modelation and to try to provide a prototype for this digital twin in this only one farm NAT. What we get in this first phase, it was this digital twin prototype. It was a very, how can I say, a very early phase, early stage prototype. So we get some results, but we see that we have to improve all the parameters, all the data, because the simulation, it was very, very, very short. We also see a very big bottleneck with the data, with the amount of data that are disposals available to try to fit this digital twin prototype. So we try to increase the number of the availability of data in the second phase, trying to close the loop with the parameters of the first year. Here we see that work package 6, we try to the automatization of the input process in these parameters, the irrigation and fertilization. The phytosanitary inputs is also regulated here in Spain, so everything it's annotated and registered in the book. And also the weather and climate data. We have a lot of agronomical stations around the country, so we try to get that data. And also establish these automatic connectors, so the parameters and the data go automatically to the model. In the work package 7, we try to automate the automation of the outputs. So we see in the farm the results of the farm work, which one parameters give us, and how we can automatize the output and incorporate that in our digital twin. Also the harvest production, the atmospheric emission, because we were also trying to see the carbon print, the footprint of carbon. Yeah, and also the state of the leaks monitoring, how the leak situation. We have using some manure to fertilize, so in the near rivers, and see how they are affected by the fertilization in this field. Also, we try to close the loop, see how simulate this cyclid several years, season and seasons, and try to go through the several years and see the results. What we achieve in the second prototype, we see a new twin version with automatic data connectors. We update the cloud deployment. We start to use a very large amount of data, so we need a new cloud deployment. We extended the validation. We see how we interact with several neighborhood farms. We establish a functional demonstration in this farm network, and we establish the foundation for the phase 3 for a full farm network. So we see that farmers share results, about pets and pests and about the environment. So we see that this phase 3 is needed to share the data for neighborhood farmers. So in the phase 3, we see that we need a very strong power data computation network. So we try to include the artificial intelligence models in the twin networking, the twin network. So we start to get a lot of more powerful results and more realistic simulations. So in this work package 10, we start to establish the node dependence in our digital twin network between neighborhood farms and see how the inputs and outputs affect one to another. We establish the specification for this relationship, mainly in the water resource and in the pest control management. This was the more important vectors for this interdependence farm network. So we design several algorithms to support this dependence. In the work package 11, we see how they affect between them. So we infer relationship, not explicitly model, not what we see, but we have the intuition that they exist. We see also the economic benefits, try to incorporate economics revenue model, revenue simulation, and revenue segment for this platform. And also we start a new line because we see that we have a lot of a large amount of data available, but it didn't get enough. So we create synthetic numbers of data to overcome this gap about the ability of data. So we put in action this third prototype, and we see that we establish a paper submitted for an international journal about digital twin for these small scale farms. This paper is available in the Open Project repository. We have a website for this project. You can see as gedefec.es if you want to consult any this paper submitted. Also, what we achieve, what we think about this 3 years project. We have achieved TRL5. We think we are near industrial field. We established a paper in the knowledge repository. We have several professional press publication in specialized media. We have this project website with the results, and also with simulators where you can play with them. We were in several trade shows specific for agriculture and for farms, sharing the knowledge that we develop, and we validate this digital twin in this real pistachio farm in the middle of peninsula. So what we think that we bring to precision agriculture, we see that we need to connect, thinking very well about what are available and what are not available, and we need to see the kind of sensor that is disposable, the kind of sensor we need to include in our farm, and also another technologies like remote sensing and image sensor from satellite sensor. Also, we see that the artificial intelligence is a very powerful technology that we help us to improve the results of the digital twins and to help in the decision support system for the farmers. So we think that we have to develop a digital twin specific for each kind of crop, for each kind of farms, and for each kind of size, because everything is a parameter that is going to have the influence in the digital twin and in the algorithms that we are going to develop. So we think that is a very powerful technology. There are a lot of study cases, but right now we are trying to scale to TRL 6 or 7 with bigger farms and some generic farms, not specific for pistachio. So let's see what are going to be the results, and if we are going to share this result, because we see that the 60% of the knowledge that we develop for pistachio farm, it's the same that it's available and it's going to be useful for develop another digital twins in another kind of crops. So thank you very much to everyone. That was the results of the GEDEFEC project. And if you want to make any question, have some doubt, please feel free to tell me.